My name is Tony Travouillon. I'm a researcher at the Australian National University. I'm an astrophysicist focusing mostly on instrumentation for ground observatories and space projects. Antarctica is an interesting place for astronomers because it's got some unique characteristics that are very close to space. So for example, we have long nights. We also have very low temperatures, which are also very close to the temperatures that we can get in space. And so the performance of telescopes is very, very high in Antarctica. And the difference with space is that you can go there regularly, you can upgrade your equipment, and therefore you're not stuck with a given technology. Now, one collaboration we are currently trying to start is between France, Australia, and the US to introduce a very vibrant topic at the moment, which is called Transient astronomy, or astronomy in 4 dimensions. For the longest time, astronomy has been something where you look at the sky and nothing changes. But it's not really what's happening, because you've got stars exploding, you have stars merging, and so the universe is very much alive. And to catch those events in the act, you need to monitor the sky every night in the exact same way. And so we need to basically take into account the time effect. That's the 4th dimension. To do this, currently we are spending a lot of efforts and collaborations around the world around big projects like the Vera Rubin Observatory in Chile, which is essentially a very wide field telescope that's going to look at the same stars every night and essentially subtract one night from the other, taking the difference between images to look for those differences from night to night. Now, Antarctica is great to do this kind of sciences, and we're hoping to do similar projects over there, but in the infrared. So we want to be able to survey the sky every night, as much stars as possible, very, very quickly, but at a different wavelength. And this wavelength, the infrared, opens a new element, because most of the universe is actually hidden from our eyes because of dust. And so we'll be able to see things that other telescopes can't see. So beyond astronomy, the collaboration can really grow from those kind of experiments, because once you bring telescope to Antarctica to do astronomical sciences, you can use the same facilities and the same telescope to do more. For example, tracking satellites in space can be done with the same telescope. It's an important topic right now because there is more and more satellites orbiting around the Earth, and there is a space safety issue that we are facing, where satellites can eventually collide and then essentially ruin the entire low orbit access. A third area where telescopes are useful is for space communications. So we know that there is projects to go to Mars, to go back to the Moon, and so high bandwidth communication will need to rely on point-to-point communication, laser communication basically, or encrypted communications even. And so these are not using broadcasted methods like radio signals, but more like telescope-based laser communications between points. And so the same telescopes can also be used in Antarctica for this purpose.